If we have local damage to area V1, we have something that's called a scotoma. So we know that area V1 is organized retinotopically. So one direction along the cortical sheet of V1 corresponds to one direction in visual space, and in another direction in area V1 corresponds to a different dimension in visual space. If we damage a local region in this retinotopic cortex, we get what basically amounts to a blind spot. So if we have a local scotoma in area V1, now we can't see things in that one region of visual space. Similarly, for area V2, you can get scotomas. Interestingly, if we go deeper into the ventral pathway and we start getting selective damage to these later areas, you can start finding deficits where people can no longer recognize particular classes of objects. And this general category of disorders are known as agnosias. And you can have agnosias for different things. So you can have object agnosias, where patients who have these disorders can no longer identify particular kinds of objects or identify objects in general. And then there's specialized forms, for instance, in the case of faces, where damage to the regions of the brain that seem to be involved in face processing causes an inability to recognize faces. And this is called prosopagnosia, or face blindness. And you might have heard of a very famous neurologist named Oliver Sacks, who wrote a book about prosopagnosia and who actually, it turned out, had prosopagnosia himself, called The Man Who Mistook His Wife for a Hat. And basically, patients with prosopagnosia, even though they can operate in the visual world, they can recognize objects, have a great deal of trouble recognizing faces. Now, if we go to the other side of the visual world and we start looking at what happens when you have lesions to different regions of the dorsal pathway, you see a very different pattern of deficits. So if we find patients who have damage to area MT, you find a disorder called kinetopsia, which is basically motion blindness. So these patients, in spite of the fact that they can recognize objects, they can see the world around them, are unable to process motion. So to them, the world looks like a series of disjointed frames rather than the fluid moving experience that we have. And as you might imagine, this is a very debilitating disorder because things like crossing the street suddenly become very difficult because you can't estimate the motion of cars and estimate when they're going to come and potentially run into you. So it's a very striking disorder. When you start lesioning the parietal cortex, you start getting deficits like visual neglect. So remember that these areas seem to be evolved in our ability to move our attention from one part of our visual field to another part of our visual field. In the case of visual neglect, if we have unilateral or one-sided damage to parietal cortex, some patients will have a syndrome where they can no longer pay attention to an entire half of the visual field. So these people, if you put a plate of food in front of them, even if they're hungry, they'll only eat half of the food on that plate and they'll ignore the other half of the plate. Or if you ask them to draw a clock, they'll tend to draw only half of the clock and they won't actually draw the other half. And to these patients, even though to an external observer this seems like a very unusual syndrome, this seems perfectly normal to them. Some patients with visual neglect will also have an experience that half their body doesn't belong to them, and they'll run into things with the other half of their body, or they'll feel like it's some sort of foreign entity. So some very complex deficits can occur when you have visual neglect. If you have damage to both hemispheres of parietal cortex, you can get something called Balance syndrome, which results in something called simultagnosia, which is characterized by an inability to direct attention anywhere in the visual field and an inability to experience the world as a whole rather than as individual parts. So patients in general will have a hard time orienting to new information, and there's a whole wealth or a whole host of different deficits that these people see. So you can start to see that there's actually a very complex and somewhat modular machinery where if we damage individual pieces of it, we can get very interesting and oftentimes very debilitating disorders that are very specific. And those specific disorders give us clues about how the visual system is organized.